Hey, in this lesson, I want to talk to you about possible outcomes when you have compound events. Okay? We've talked about possible outcomes before on simple events, or like if you have one event that happens. For example, if I ask you how many outcomes there are when I toss a six-sided number cube, then you would tell me that there are 6 different outcomes that could occur. 1 through 6, and they're all equally likely because the faces are all the same size. Okay? So what happens if you have 2 events? For example, if you have a question and it says, if you spin each of these spinners once, how many possible outcomes are there? All right, so I'm going to look at my spinners, and I'm going to notice that on the spinner I have 3 different outcomes that could occur. And on my second spinner, I have a total of 4. But if I spin these, like this one first and then that one, I could get combinations. So it's maybe not all that easy just to say, hey, boom, look at it and see this is what it is. One way that I could figure this out is I could list what the outcomes are. For example, if I spin this spinner, I could get an A. And then if I go to this spinner, I could get a 1. I could also get A on the first one, but I could get A and then a 2 on the second spin. I could get A with 3, A with 4. So I think you see that what we're doing is matching up each individual outcome on the first spinner with each individual outcome on the second spinner. I could get B on the first one and 1 on the second, or B2, B with a 3, B with a 4, or I could get C with a 1, C with a 2, C with a 3, or C with a 4. So listing them makes sense. The thing that I want you to notice is that we could just find the shortcut of all 12 of these by saying, hey, how many possible outcomes are there on the first event? There are 3. And how many outcomes are there on the second event? 2. Excuse me, not 2, there are 4. And if I multiply those together, 3 times 4, that would tell me how many possible outcomes there are. And I could have listed all those and figured that out. No matter how I do it, I know the answer is 12 different outcomes. Let's get a question like this one. We're dealing with letters and numbers. My next question over here says, how many different 2-letter and 3-number combinations can you make? It's almost like making license plates, okay? So again, we're dealing with multiple events because we're choosing, 2 different letters, 1 letter per space, and 3 different numbers, 1 number per space. So I essentially could think about this as events that I choose each one of the spaces for. For example, if there's 2 letters, I know there are 2 spaces. There are 3 numbers, I know there are 3 spaces. So like in the very first spot of this combination of outcomes, how many outcomes of letters are there? Well, the English alphabet has 26 letters in it. So in the first spot, there could be 26 letters. In the second spot, I have letters again. So that's still 26 different options. Letters. All right, what about numbers? How many numbers are there? In our number system, there are only 10 digits, 0 through 9. 0, 1 through 1, 2, 3, 4, 5, 6, 7, 8, 9. So I could have 10 digits to choose from, 10 digits, and 10 digits. So all of these are numbers. Now, could you imagine how long it would take to go through and list all of these different outcomes? Like A, 1, 1, 1, or A, 1, 1, 2, A, 1, 1, 3. I could possibly list all of those outcomes. But this shortcut of multiplication called the fundamental counting principle says, hey, all you really need to do is to multiply your number of outcomes for each event by one another. So I could go, hey, all right, let's multiply this out. 26 times 26 times 10 times 10 times 10. And this would actually be that there are this many possible outcomes for putting together 2 letters and 3 numbers. Wow, that would be a lot. I hope this helps you.